This is going to take a look at DeMoivres theorem, two different types of DeMoivres theorem that can come up. The first one then is, we're going to take a look at the easier method of it. You're going to be given the original Z, the original, and asked to find a power. So what we're talking about there is that we'll say you're going to be given Z is equal to 2 plus I. You're going to be asked to put Z to a power of something. To do this, what we need to do is we need to get into polar form, and then we need to get the modulus to the power of or, and the argument is multiplied by or. This thing in the red box then, this or cos theta plus I sine theta to the power of n, it's hard to see there but it's a little n, is equal to or to the power of n cos n theta plus I sine n theta. Now, going through that, that's in the log tables. It says there that you have or is going to be your modulus, your cos of your angle plus your I sine of your angle, and then that's put to the power of something. When that's put to the power of something, the or value is put to the power of that, and then inside your angle is multiplied by it. That's what the n theta stands by, it's being multiplied by it. So let's take a look at two questions like this, and we'll move on and take a look at the more difficult ones. So here we have a question at example 8.16. It says z is equal to the minus root 3 plus I, where I to the power of z is equal to minus 1. That bit at the end doesn't really make a whole pile of difference, they just tend to write that. And it says use DeMoivres theorem to write z to the power of 4 in the form a plus b root ci, where a, b and c are elements of z. Now all that's telling us here is that z is a, b and c are going to be integers. We're given z and we're asked to put it to the power of something. So that means we know that we're doing the easier question. So to start with this question, we'll do what we have said up here. It says to do this we need to find polar form of a complex number, so that's what we're going to do. To find polar form, I'm using my calculator, and what I'm doing is I'm pressing the shift button, then I'm pressing plus. And when you do that, just an arrow, when you do that, you will see that you get POL on your calculator with an open bracket. I'm going to type in there minus the root of 3 for the first part of my Z value. And then instead of writing I, because there is no I in the calculator, they know that the second coordinate is going to be an imaginary part in the calculator. So it's just a 1 in front of the I. If that was 2I, I'd write a 2 here. And I close my bracket and I press equals. And what we'll see comes up there is we see that or is equal to 2 and my angle is equal to 150. If you're getting something funny here, it might be that your calculator is in radians. So to change that, you need to go into shift and mode, or shift and setup. Press the number 3 then to have it in degrees. Yours might be in 4, which is radians. So the next thing that we have to do then is we have to put it into our polar form. And our polar form is just what we have written in this red box, this section here, or cos theta plus I sine theta. So I have 2 cos of 150 plus I sine 150. The other thing to take note of here is if you ended up with a minus here. If that happens, what you do is you take it from 360. So if that's a minus, take it from 360. Okay. So now that we have our or value in our polar form, or z, sorry, in our polar form, I'm going to write z equals. That's my first step. If I go back up to this bit up here, where it says I need to find polar form of the complex number. All I'm doing then is I'm using the bit in the red box to say if I want z to the power of 4, I know that I put the 2 to the power of 4 and then I multiply my angle by 4. All I'm doing then is things go back into the calculator and they go back in a specific order. What I have to do first is I have to find the cos of this. And in my calculator, when I go and I check what the cos of 150 times 4, make sure that 150 times 4 goes into the calculator, I'm getting minus a half. Then what I have to put into the calculator is sine of 150 times 4. Not the I part, just the sine part. And when I put that into the calculator, I'm getting minus root 3 over 2. Now that's stuck to an I. Think of that like an x value. I check what my 2 to the power 4 is, and that is 16. So I know that z to the power of 4 is equal to this. So z to the power of 4, when I multiply 16 times minus a half, is minus 8. 16 times minus root 3 over 2 is going to be minus 8 root 3i. And that is my answer then. So that's the first question finished. If you'd like to take a go now of the second question, this 8.17, you can pause the video and I'm going to go through that answer now. So for this one, same idea applies. This here is my z value and they're telling me to put it to the power of 8. So it's a shorter version of what's happening above, but it's still the same idea. It's telling me to use DeMoivres theorem and expressing it to the power of 8. So I'm going to do what I did earlier and I'm going to say that my or value, so I'm going to type in shift and plus, and I'm going to say 1 comma, and the shift and the close bracket is how you do that. So if you're looking for the instructions, you know that you have shift plus, then you get pole and a bracket open. You're typing in 1, the comma and 1, and where that comma comes from is by pressing shift and the close bracket button. So when I do that, I'm seeing that I'm getting this decimal, or equals 1.414. So what I want to do is I'm going to write or equals, and I'm going to just leave that for a second. I'd rather not have that if at all possible. And I'm going to go across, I'm going to press the over button, I'm going to check and see that I can get my angle as 45 degrees. Now what I'm going to do is, because I have this mad value, I'm going to just press on my calculator. The answer button is down beside the equals. You press answer equals, and what happens then is it gives you that figure meant the root of 2. So if it gives you a funny figure, all you're doing is press answer equals, and that's going to give you that. Now what I'm going to do is I'm going to just call this z, and I'm going to write it into polar form. So root 2 cos 45 plus I sine 45. Now, I know they want that to the power of 8, so I'm going to say that's root 2 to the power of 8, and that's cos 45 times 8 plus I sine 45 times 8. And again, what I'm doing in the calculator here is I'm putting this into the calculator first, and when I do that, I see that I'm getting 1. And then I'm going to put plus I, or if I want to do the I afterwards, that's fine. And I'm putting this into the calculator. And when I put that into the calculator, I'm getting a 0. So that's 0, and your I goes after it. I check what root 2 to the power of 8 is, again, do that in the calculator, and that gives me 16. So I have z to the power of 8 is equal to 16 times 1 plus 0i. Because it's asking in this question, use DeMoivres to express this in its simplest form, I then just need to multiply that out. That z to the power of 8 is just equal to 16 plus 0y. You can write it as just 16 or 16 plus 0y. Totally up to yourself for that. And then there is my answer. And that's that question done. So now that we've done the easy questions, let's take a look now at the more difficult questions. So this is a harder type of question. This type is when we are asked to solve or to find roots of a complex number. We can also be asked to find z given z to a power. So to do this, what we need to do is we need to find find polar form, which is what we were doing. Find general polar form. Now our general polar form when we were doing it is slightly different. So instead of this one, we have or cos theta plus 360 n plus I sine theta plus 360 n. The only difference is what we do is we're going to keep everything in terms of in terms of degrees rather than radians. Now we spoke about radians before, but radians basically are just another form of degrees. So we know that 2 pi, which is inside here, is 180 degrees. Pi is 180 degrees. So pi times 2 is 360. So that's really the same thing as 360n. So in radians, pi is equal to 180, and we did that earlier in complex numbers. So what we're going to do is we're going to keep everything in terms of degrees, and we're going to use this formula instead. Okay, the third thing we're going to do then is we're going to put it to the power of the amount over, 1 over the amount of roots you're asked to find, and substitute in values for n starting at 0 and going up to the number before the number of roots you were asked to find. So let's take a look at this question here, and it might make a little bit more sense when we're doing this. So if I look up here, if I look at this example 8.18, it says the complex number w has a modulus 3 3/8 and an argument of 2 pi over 3. Use DeMoivres' theorem to find in polar form the 3 complex cube roots of w, that is, find the 3 values of v, which v cubed is equal to w. Now I'm going to, instead of using this method that's down here, I'm going to go and I'm going to use the method that we have, which is when we change our 2 pi over 3 to be in regular degrees. So that's going to be 2. And then 180, because we know pi is 180, over 3. And when I check what that is in my calculator, that's 120 degrees. So now I have 3 3/8 and 120 degrees. And I'm going to check what 3 3/8 is just as a whole fraction. I'm just typing it into calculator, 3 plus 3 over 8. And that gives me 27 over 8. So they're the values that I'm going to use. And I'm going to ignore this half here, and I'm going to do it using degrees rather than angles. So I'm going to first of all use the fact that it has said in the question, use DeMoivres' theorem to find in polar form the 3 complex roots. Because they have said to find the 3 complex roots, that means that I know that this is one of the more difficult ones, because if I'm finding roots or I'm solving, or if they're asking me to find 3 values of v for which v cubed equals w, if they say that, then that means that I'm going to have to use the harder method. So to start this, the first thing we're going to do is we're going to find polar form. I'm using these bits up here to find polar form. So polar form, all I need is I need my modulus, I need my argument. This is equal to my r value, and this is equal to my theta value. They've given me that. I don't need to use the button in the calculator. So I'm going to first say then, if this is w, I'm going to say or cos theta plus I sine theta, that's or. Cos 120 plus I sine 120. There's my first step done. The next thing I'm going to do then is I'm going to find general polar form, which is this blue highlighted bit up here on the top. And I'm going to sub everything into that. So that's going to be w is equal to, that's going to be 27 over 8 cos of my 120, and what I'm adding in there is my plus 360n plus I sine 120 plus 360n. There's my general polar form. That's my step 2 done. All I've done there, all I've changed is that I have added in this little thing here. It's the only difference between polar form and general polar form. General just means that you're going to be able to change it, so that's why the n value needs to be in there. And what we're doing is each n value that we sub in, we're going around if I draw the little Argand diagram, if I have a point here, all I'm doing is I'm going around and back again, because we'll say if that was 30 degrees, then I'd have to go around again, add 360 on this next one, then it'd be 390. And you can keep going and keep going, because we only go up to 360 in this circle, but there are obviously more degrees than that. You can go up to infinity with degrees. So this allows us to find them by just going around that circle again. So now that we found general polar form, what we're going to do is we are going to put, step 3 says put it to the power of 1 over the amount of roots you're asked to find. So here we're asked to find 3 complex roots. So I'm going to have to put this to the power of 1 over 3. And the other way that I'm saying this is because if they have written up here, I have w, and w is equal to v to the power of 3. So that means that this is v to the power of 3. So if w is equal to v to the power of 3, and I'm asked to find v, then that's equal to the power, that's equal to w to the power of 1/3. So that's where that's coming from. But all we have to remember is how many roots they're asking for. It's going to be 1 over that value I'm putting it to the power of. So now I have v is going to equal 27 over 8. I always put that to the power of it. And then the rest I'm multiplying it. So that's 120 plus 360n, but I am multiplying that by 1/3. Plus I sine 120 plus 360n. And again, I put my 1/3, same as we were doing above when we were asked to put something to the power. That's what DeMoivres does. It allows us to put the or value to the power and multiply the angle by the power. Now the last step here, if I just move back, step 4 at the top, it says substitute in values for n, starting at 0 and going up to the number before the number of roots you're asked to find. So what that means is I must find 3 roots. So I'm starting at 0, I'm using 0, 1 and 2. That gives me 3 roots, 0, 1 and 2. That's the 3 roots that I want. And I'm going to the number before the number of roots you were asked to find. So I'm going to the number 2 rather than to the number 3. That's what that means. So if I move this down a little bit, all I'm going to do now is I'm going to just change the color so that I can see the different ones that I'm doing. I'm going to use n equals 0. And when I do that, I'll have v is equal to 27 over 8 to the power of 1/3. Cos of 120 plus 360 by 0. All of that is multiplied by 1/3. Plus I sine 120 plus 360 times 0 multiplied by 1/3. So when I put my 27 over 8 to the power of 1/3, I get 3 over 2. What I'm going to do now is I'm going to, in my calculator, multiply 360 by 0, which is 0. Add that value to 120. 120 plus 0 is 120. I'm getting 1/3 of 120, which gives me 40. So really, I am getting the cos of 40 plus I sine 40. Okay? Now, if I look at this question up here, generally from here I'll put that in the calculator and I'll put that in the calculator. But because they asked me for my answers to find in polar form, I actually don't have to do anything else. And you'll see if you do put them in the calculator, you're going to end up with a really awful looking fraction or an awful looking decimal. That's why they do that sometimes. I have one of my answers. My answer is this one here. Okay, so that's one answer. Right, next thing I have to do then is I have to change my color. And then I'm going to do n equals 1. And when I do n equals 1, I'll have v is equal to 27 over 8 to the power of 1/3. I'll have cos 120 plus 360. And instead of n, I know I'm putting in the number 1. I keep my 1/3, and I'm going to do the same with, that's an I there. This next one, 120 plus 360 times 1. And I'm multiplying all of that by 1/3. So again, checking this in the calculator, I know that it's going to be v is equal to, this is 3 over 2, same as last time. I multiply 360 by 1, which is 360. I add it to 120, and then I divide my answer by 3. So I'm ending up with there, cos 160 plus I sine the same thing, 160. And there is my second answer. Finally then, my third answer, I'm going to do the same thing, but what I have to do now is I have to let n equal to 2. So I have n equals 2 is my last number. I'm going to have v equals 27 over 8 to the power of 1/3. Then I'm going to have cos 120 plus 360 times 2. Multiplied by 1/3, and then my sine is going to be the same thing, plus I sine 120 plus 360 times 2 to the power of 1/3. Again, in my calculator, what I'm going to do now is I'm going to start with the 360, I'm going to start with V equals, this is 3 over 2 again. In there goes 360 times 2 plus 120 divided by 3, and it's a cos of 280 plus I sine 280. And there's my final answer. So there are my 3 answers then, all in polar form. They're all values for V when the n value is changing. So they are the complex roots of that answer. So these 2 questions then are 2 separate types of questions, same idea as the more difficult question. So give them a go